Welcome everyone. Yeah, 4 p.m. is a tough time probably for everyone, but I'll try to keep you awake. So my name's Alex, I'm from the TAC in Brussels. I support VPNs for Cisco for now 9 years almost. And today I'd like to talk to you about FlexVPN, which is our new offering in terms of IPsec VPN, soon SSL VPN as well. So what I'll try to do, this is a short presentation, this is 45 minutes. So instead of talking about the architecture of the feature, the protocols, how the exchanges work and everything, I'll try to show you some use cases and show you some config and show you what you can achieve by looking at some real-life examples, or maybe theoretical but kind of real-life-like examples. And I go over 4 use cases today to show you things that you might encounter, doing business, proposing some solutions to your customers, or trying to protect your own networks. So I look at some managed remote access for multi-tenant, single-tenant. We'll look at some maybe one-size-fits-all kind of design where you can mix clients and branches and spoke-to-spoke as well. So trying to converge the existing solutions into one single design. And we'll also take a quick look at MPLS virtualization over FlexVPN. You might be familiar with the DMVPN. Now you can do that even further. You can go even further with Flex doing MPLS virtualization. So first an overview, maybe what Flex is. It's basically a consolidation of everything you could do before using a single unified CLI. And it kind of covers what you could do with EasyVPN, with DMVPN, what you could do with the old legacy crypto maps. GetVPN is out of the picture, by the way, because this is overlay IPsec only, so it's not transport encryption, it's just overlay network. You've got a different routing domain for the IPsec traffic than for the cleartext traffic. And it uses IPsec version 2. So Internet Key Exchange, that's the control channel for building IPsec. That's the next generation, and we'll see the differences with IPsec v1. So all of that above here, those 3 are based on IPsec version 1. Flex is IPsec version 2 and leverages IPsec version 2 to provide additional functionality, additional power for your solutions. So basically, if your question is, what solution should I use now to do something with IPsec v2, the answer is always going to be Flex. That's easy. It's also easier to learn one single solution, even though there's some more complexity. It's easier to learn, it's easier to sell, to maintain, it's easier to troubleshoot. So it's got a lot of advantages. So why FlexVPN? Because IPsec version 2. Why IPsec version 2? One of the reasons is, this fragmentation of the standard. There used to be lots of features like mode config, NAT traversal, dead peer detection. Some are proprietary, some are standards, some are half standards. This has all been coalesced into a single RFC for IPsec v2. So the good thing is, if it's in an RFC, everything we used to need before now is standardized, so we can interoperate between vendors. The mobile phone vendors, OS vendors, appliance vendors, everyone can speak the same language and leverage that to do IPsec VPN in a kind of consistent way. So it's got the same objectives as IPsec v1, same objectives which are authentication, integrity, encryption, but it's got some additional security. Like, you cannot starve an IPsec responder, an IPsec v2 responder with half open sessions by spoofing IP addresses. It's got a DOS mechanism. Suite B, that's the name for the next gen encryption. So AES, GCM, elliptic curve, Diffie-Hellman, and so on. So that's all mandated by government specifications and all kinds of security policies. So you've got to also move to IPsec v2 to address those needs in next gen crypto. There's more authentication options as well, notably EAP, so extensible authentication protocol between the client and the backend server. You can use any kind of EAP type authentication, let's say fingerprint reading. You can do that between a client that supports it and a server that supports it. IPsec v2 is going to be able to transport that and establish an IPsec VPN without the server having to support the specific EAP method that you're going to use. It just has to know that this is an EAP method. Hybrid is, we used to do that in the old days of VPN 3K, VPN client. You can use a different method to authenticate the client to the server and the server to the client. This is stock in IPsec v2. So overall, they are kind of the same, they are kind of different. It uses the same ports, not the same exchange. There's acknowledged notification, so if you delete, you will retransmit until you get an acknowledgement that something has been deleted. In the end, this is what we are interested in. It's more secure, it's got more options for authentication, and it's cleaner, has a bidirectional config exchange, so you can send attributes both ways, from the client to the server as well as from the server to the client. This is going to be very handy. We'll see when we do, for instance, routing without a dynamic routing protocol. So overall, if you want to learn more about IPv2, we have some presentations online. I give you references at the end of this slide deck. Of course, IPv2 has been updated by an RFC and another RFC and another RFC and so on. So it's also going to become a bit more fragmented than it was initially. We implement some things like IPv2 redirect. We've turned it into the load balancer feature. There's other add-ons to IPv2 that are or are not implemented. So you're going to have some differences between vendors and between implementations. But at least the core of the feature is the main RFC, and everyone speaks that language. FlexVPN is based on virtual interfaces. If you're familiar with DVTI, EasyVPN, you probably know about this. So you have a virtual template interface. That's a blueprint for an interface, which is going to be dedicated to a single remote peer. When I have a mobile client connecting to my FlexVPN server, this template is instantiated into what's called a virtual access interface. It gets populated with the right source destination. I can add something like I've added a service policy. I can now add specific statements, specific features on that interface for that specific client. I have a dedicated interface, I have a dedicated place in my config, in my router, to place the feature information. And I decide to send traffic to my client by routing it to the virtual access. So this instantiated interface is my exit point for my clear text traffic towards my VPN client. If I have a second client, I just instantiate the same virtual template or another one into another virtual access, and so on. And every time I add route information that tell me what interface is for what IP address. This also works for routers. If I have a router that has a static tunnel interface, that's new with IPv2, you can now get the IP address automatically from the head end. It will also trigger the same kind of V-access. So also in the case of hub and spoke, I will have the same kind of flexibility. This is like DVTI with IPv1. And furthermore, if I have a network behind my peer router, I will just keep adding prefixes to my routing table, all pointing to the V-access for my router. And the good thing is, this used to be done with the routing protocol with DVTI, the old style IPv1. With Flex and IPv2, we can actually exchange subnet payloads in config exchange. And this can be advertised by my peer strictly with IPv2. So I can now completely do away with the routing neighborship. So this will enable me to have very lightweight peerings between my spokes and my hubs by simply sending a static route once and for all when the tunnel comes up. And as long as the networks behind my spoke are not changing, then this is going to be fine. This is a fully functional Flex config. So we've added a lot of IPv2 defaults, like with IPv1 you had to configure policies, transform set, everything. This has all been turned into what we call smart defaults that have like some good values for most people, most users. You can still override them, disable them and so on. All you have to create is this default IPv2 profile. And this CLI kind of reflects the logic of the responder. So first, you land on this profile by providing an identity. So during the IK exchange, the peer provides the identity. You land on the profile, you authenticate using certificates, using EAP. Then you perform authorization using AAA. So the AAA subsystem is heavily used by FlexVPN. You could authorize in multiple steps, do user group authorization if you like. You can do some accounting. And once this has all been done, typically you will assign an IP address if needed in this stage. Then you instantiate the virtual template into a V-access. And the V-template tells you what tunnel mode you use. You can do IPsec pure tunnel mode, you can do GRE over IPsec. Now in 3.12 we are going to add tunnel mode auto, so you can even adapt to the tunnel mode that is required by your client, which is very handy. We'll see an example of that a bit later in the presentation. So functionally speaking, what we'll deal with is three main protocols. We'll have the IPv2 exchange between the client, any kind of client, mobile, laptop, and the server, the Flex server. On the right-hand side, we'll have radius between the FlexVPN server and the backend server. If you do EAP, you're going to have the client as a supplicant that's going to speak EAP with the backend server via the FlexVPN server. So the Flex server, what it will do is simply decapsulate the EAP messages from the IPv2 packets, re-encapsulate them into radius, and that back and forth. So the EAP exchange is simply passed, as the postman by the FlexVPN server. It's not looking at what's inside the packet, just passing it in between. And at the end of the EAP exchange, AAA server is going to simply send a success message to the FlexVPN server. So if you do certificates or pre-shared key, that's only IPv2 based. That's purely between the client and the server, no AAA involved. Except that now you can have your keyring, your pre-shared keys on the AAA server. So during the pre-shared key exchange, you can go and fetch the local and remote pre-shared key from your AAA storage. So what's good is if you add a peer or modify the credentials of the peer, you have to change it on AAA and not on the router. When you do EAP, as I said, it's just between the client and the server and the AAA server. When this exchange completes, the AAA server sends a success message along with all the attributes for the client. If you provide a username and password to the AAA server, all the attributes for that account are going to be provided back to the Flex server. And if you do radius authorization and accounting, of course, that's going to take place between the Flex server and the radius server. So first case we're going to look at is some managed remote access. What I want to do, I have this headend that has two VRF behind it, the blue and the green. This is a single customer, multiple VRF scenario. I've got different departments, different users from those departments. They have certificates, individual identity certificates. I want to place them in the right VRF based on my AAA authorization. And I want to apply some features like quality of service. Maybe some users need a bigger pipeline than others, maybe different firewall rules. All of my features in this example are going to be driven by my AAA server. How do I achieve that? First of all, I want to place my virtual access interface into the correct VRF. So the decapsulated packet will pop out of the VAccess in the right VRF and be routed according to the routing table of that VRF. That's all going to be told by my AAA server to the Flex server. Features, the same thing. So let's look at the config. I'll try not to kill you with configs, but I'm trying to use the config to show you two things, to show you how things work and show you that it doesn't change much in the end. When you configure it, there's going to be little details that change in the config, but it always remains quite simple, quite short. And so you'll never have an exponential huge config with FlexVPN unless it's a very specific design or a bad design. So there's always a way to make it very concise. I simply set up my radius server. I only have one. I will use a certificate matching to land on this profile. I set up what's called an mmangler. This is just to extract, in this case, a common name from the certificate distinguished name. And I'm going to authorize my users based on their common name. When I landed on my IPv2 profile, I will do RSA signatures both ways, client to server and server to client. And this is the authorization statement that enables the whole per user feature functionality. I will say that I want to authorize my user who's using certificates by applying this radius AAA list using the result of my CN extractor. Once this is all retrieved, I've got a set of attributes. I clone my vtemplate, which is completely generic. It's got no IP address, no VRF, no features. I will add all of that based on my AAA attributes. And so this is all I need to have on my radius server. 2 user accounts, 1 address pool for the different VRF. Maybe they don't use the same addressing. VRF statement, IP and number to a loop back in the VRF. This is all I need to place my user in the right routing domain. Everything else is just for additional features. I've got my service policy for low bandwidth for the top user and the zone for ZBF. This is all applied at runtime on my interface. This is actually parsed, parsed by the CLI parser, and the feature is configured that way. And I end up with a specific VAccess with the right settings for my user. Now, what if I have multiple customers? Let's say that I have this MPLS core behind my Flex server. I want to provide a single entry point for my different customers. Let's say these are like small companies. I have a small router with with a common responder, and based on the credentials of each user, I want to, well, based on the profile of each user, I want to direct them to the AAA server of each specific company for authentication. What I'll do here is, this user comes in, I will land them on a profile based on their identity, authenticate them to the AAA server of my customer. So this is all managed by my customer as far as authentication goes, and then place them in the right vAccess with the right settings. So this time I don't want my customer to go and configure things on my router. So I won't use the authorization feature. I will just let the customer AAA server authenticate my users, and the VRF information, quality of service, I don't want my users, my customers to override that, place themselves in the wrong VRF, and so on. So I'll manage all of that by having separate profiles and vtemplates for my different customers. In other words, this is the example for the blue customer. I've got a specific AAA server reference. I've got a set of attributes which are local, which just tell me the address pool to use. I land on the right profile based on the config in my client. So I distribute profiles. This was for AnyConnect. I distribute profiles that have the right identity configured. So it will just enable me to land in the customer's IKv2 profile. I configure EAP authentication, and I point my EAP authentication to the specific customer's AAA server. I authenticate using certificates. This is mandatory for the server. And the authorization I want to perform, I'm not going to use anything returned by the authentication server. I will solely use this for the address pool and static settings on my virtual template for the VRF. So for everything, I have these settings on the virtual template, which is specific to this IKE profile, which is specific to this customer. So now I have retained control on everything, but I still let my customer offload the authentication work. And again, it doesn't have to be username and password. It can be anything that they support and that the client also supports. So now we can take it to even one step further. Let's say that I have some clients and some branches, some spokes, some home offices, some small offices, small branch offices. I want to mix all of that into a single consolidated remote access functionality. In this case, I go back to the one single AAA server managed by myself. I manage it. I've got my hub with some VRS behind, so every circle is an interface. And I would like to have some clients, mobile clients, Windows clients, AnyConnect clients, anything that supports IKv2. I would like those to be placed in the correct VRF based on authorization to my AAA server. And I also like routers to connect to the same responder and be placed again in the right VRF. So those are branches or home offices. Let's say that I want the branches to be able to build ad hoc spoke-to-spoke tunnels between themselves as well. Let's say that I don't want my single user small network at home to be able to do that. So I would like to enable spoke-to-spoke functionality on a per peer basis. But this is quite a complex solution, but still it can be offloaded to AAA in almost its entirety. So I'll go back to my setup with a single profile, single template, minimalistic, and I let the way that the peers authenticate to the server be the differentiator. These branches will use certificates. These users will use EAP. Doesn't mean they won't be using certificates inside EAP. They could do EAP TLS and use certificates. But I will differentiate the way I authorize based on whether this is a remote access client or a branch router. And surprise, the config is actually really short. It's very short. I have a single profile. I've got two AAA statements, one for authentication to EAP. I have a single AAA server. One for the radius authorization. EAP is going to be used for my clients. Radius authorization will be used for my branches. This single profile, I've got as many match statements to land on it as I need. Different types of clients will give a different type of identity. So I'm going to just put whatever statements are required based on the types of clients I want to serve. This ensures that everyone will land on the single profile. I will allow both RSA signatures, so certificates, and EAP as the authentication method. You know, when my client comes in, it will tell me how it wants to authenticate. I will just let it do one or the other. I will always authenticate to my peer using certificates because it's mandatory for EAP. And then I'll have two authorization statements. If my peer uses EAP, it's a remote access client. In that case, it's already got the set of attributes returned by the AAA server during the authentication stage, because it happens between the client and the server. But at the end of the exchange, I get a confirmation message from the Radius EAP server, and I get a set of attributes for that client at the same time. So I can just reuse that. I don't need another round trip to the AAA server to authorize. So I've got my client authorization sorted out. If I have a branch authenticating with certificates, I simply have an explicit step saying, now that you've done the IV2 side of the exchange using certificates, you just go to the Radius server and present the username extracted from, in this case, this is the FQDN that I will use. So I will FQDN identity, I will send it to the Radius server and get back the attributes for my branch. And again, I have a vanilla, unconfigured vtemplate. In this case, I use tunnel mode auto. Why? Because branches doing spoke to spoke, they need NHRP. If they need NHRP, they need GRE. But my Windows client, it doesn't support GRE. So this allows me, it starts in 312S, this allows me to follow what is proposed by the client using tunnel mode auto on the vtemplate. This is quite handy as well. Otherwise, you would need two profiles and two vtemplates. And on the Radius server, this is all I got. My user account has probably a password if I want to do password authentication, and all of the stuff I showed before, VRF, features, everything is provided to put on the vtemplate. Same as in the first two use cases. The branch, in this case, has interface config plus an HRP configuration for enabling spoke to spoke. Once this is configured on the vAccess, my branch will receive indirections from the Flex server, and it will be able to do spoke-to-spoke tunnels. Now this is quite interesting. On top of having spoke-to-spoke statements added, I have these route statements on the authorization attributes. So this is what I was telling you about IPv2 routing. Let's say I have completely static addressing scheme. I don't have any subnets that will move from behind my branches to behind other branches and so on. It's very, very stable. What I do is, I will use this statement to send a summary prefix to my branch. That's route set. So this one way, when I authorize my branch, I'll send some attributes down its way, saying, you know what, I'm protecting this network. We don't need a routing protocol. And I will accept any such payload sent the other way by my branch. So my branch will also authorize the server and send its own prefix or prefixes. So whatever it protects is going to be sent in an IPv2 subnet payload. So now I've advertised non-default, non-trivial prefixes without the need of routing neighborship, which is very, very good because you don't need to care about convergence, scaling, you don't need to care about any of that. You might say you don't want to let the branch control what network you see as behind the branch. What if it advertises 0000? You can also do a full AAA managed routing policy by having, instead of route accept, you have route set local. Route set local tells you, don't accept anything because you don't have this route accept any. Rather, this 192.168.1.0, I forgot the subnet mask, is what is behind this branch. So now you've achieved complete control over what network you see behind which branch office, completely based on AAA. So this has obvious advantages in that change management is going to be much easier. You don't have those access lists to update, you don't have anything to change on the router itself. You simply go into the profile on your AAA server and you change the subnets in there. And we'll see the last example that you can also use these minimal route set statements to bootstrap a complete neighborship with BGP or any other routing protocol, and that's going to be quite handy. But this is very useful for a light deployment. You just don't need to care about dynamic routing. Okay? On the spoke, I would like to show you the config of the spoke. It's slightly bigger than what you might know if you know DMVPN. There's one more interface involved, and I'll show you why in a second in the next slide. So the profile is the same. We have some default authorization to make your life easy. we have one tunnel interface that will initiate the tunnel. You always need to have one static tunnel to initiate the connection. The hub has a vTemplate because it's the responder. It just sits there listening, something comes in, it instantiates the vTemplate into a vAccess. But the spoke needs a tunnel interface to actually initiate the tunnel to the hub. It's got the NHRP statements that are required for spoke to spoke. So you need to have these on the spoke plus the matching ones on the hub that I showed in the previous slide, so on both sides to enable spoke to spoke functionality. You also need a vTemplate on the spoke. Why? Because each spoke to spoke ad hoc tunnel is going to be a point-to-point tunnel between the spoke and the other spoke. So you need to have similarly configured vTemplate and tunnel and reference each other in the config. This is because, I told you the hub is a responder. It instantiates a virtual access per spoke. For each ad hoc tunnel, the initiator spoke first instantiates a virtual access, initiates the tunnel from there, and the responder also instantiates a virtual access in response. So this means you've got point-to-point everywhere. For example, you can do quality of service on this specific link. Even better, before you could only do per tunnel quality of service on the hub down towards the spoke, but not from the spoke towards the hub, because it was a multi-point interface, no mapping, no registration. Now you can actually do bidirectional QoS, not only from spoke to hub, but also from spoke to spoke. And you can even fine-tune it further by authorizing your spoke, your remote spoke on this side if you have a AAA server or policy. So you can even think even bigger. But so the basic functionality of having features on the spoke-to-spoke tunnels, that's now possible thanks to flex and point-to-point interfaces. Well, I think that's a very, very big plus. So my last case is going to be about virtualization. I want to virtualize a lot. I want to have a lot of different VRF. If I want to have a single interface, single tunnel per VRF, it's going to grow linearly. I don't want that. I want something simpler. So I have my MPLS core behind the hub, and I'll have my spokes peer with the hub with VPN v4, with MPI BGP, and they will exchange VPN prefixes. And I will use a single IPsec tunnel between my spokes and my hubs to carry each VRF. So per prefix I will have one label, sorry, per VRF I will have one VPN label, but it will all be transported over the single IPsec tunnel in the global table. So VRF blue and red, they are both going over the same IPsec tunnel. I also want to enable spoke-to-spoke functionality. In DMVPN you can't do that. With Flex you can actually do it. So we've added some resolution mechanism for VPN labels, where over this ad hoc tunnel, on-demand ad hoc tunnel, I will have both VRF red and green and whatever I like, because there's a VPN label resolution mechanism between the spokes. And guess what? The config is pretty straightforward, at least if you know MPLS VPN and Flex a little bit. Single profile, single vTemplate, all in the global. This default authorization policy, it gives me the default route set, which will simply publish the IP address on my virtual access to the peer. And I will have the same on the hub and the spoke. So the hub, by virtue of this statement, is just going to send the loopback1 IP address, which is its own end of the VPN tunnel, its own side of the point-to-point VPN, is going to send that to the spoke and say, you can reach this IP address over your side of the tunnel, over your tunnel interface. It enables NHRP for spoke-to-spoke functionality, and this is a statement that enables control over MPLS by NHRP. So this will enable the dynamic VPN label resolution. Again, it's pretty short config. In BGP, all you have to do on the hub side, you listen to incoming connections using the dynamic neighbor feature, which is very handy. No need to configure spokes one by one. You can just listen and establish neighborships like that. You source your updates from the loopback that you just advertised. So your local BGP endpoint is going to be reachable over the VPN by the spoke. And you simply peer with VPN v4 with each spoke that comes in and gets mapped to the peer group spokes above. And within each VRF, you're going to send, in this case, a summary prefix. You could send a default route, whatever you like. And that's it. That's all you need. Apart from the peering towards the core, of course, which I didn't show on the config. On the spoke, well, same deal as before. We need one static tunnel, a similarly configured virtual template, single profile. All that's interesting on this profile is we also use this default authorization policy, which has, again, the effect of advertising our loopback one up to the hub. So now we've got one IP address seen by one side, one IP address seen by the other side. We just have the 2 points that are needed to establish our BGP neighborship. Again, you know, MPLS and HRP, both on the tunnel and the vTemplate, and that's all we need. Once we've enabled that, we just configure a VPN for peering with our hub as the neighbor. We send our own prefixes. In this case, we have BGP running, so no need to bother with IV2. We just send our own prefixes in BGP. Anyway, this is VPN v4, so we have to. And this is all you need on the spoke. So again, we've achieved quite a complex scenario with a very minimal config. So this is what I wanted to really show you today, is FlexVPN offers a lot of options, a lot of possibilities. And so far we've shown in these breakout sessions at Cisco Live this year and last year, we've shown the feature architecture, how it works, you know, all the protocols involved, the exchanges involved. There's a lot of things going on. Sometimes it's quite hard when you see all the building blocks to find out what you can actually do with it and to map it to your own use cases and scenarios. So that's what I've tried to do today. I hope it was informative. Now, if you want more background information about FlexVPN, you can find recordings of these sessions. This year it was split between remote access with lots of practical details about the different clients, how you can set up connections in your lab, what are the requirements for certificates, and so on and so on. Lots of details about EAP. There was an advanced session about MPLS over Flex, multicast over Flex, redundancy scenarios. That one is quite interesting as well. And the one from the year before is kind of the same content, but in a single presentation and with much less focus on remote access. So I would say if you have to watch something, try to watch the two from Milan 2014, and that's going to give you a lot of things to practice in your lab. And the config guide on Cisco is currently the only source of information we have. So we have a book in the iOS and iOS XE config guide about FlexVPN. We are working on more, but still working on it. So be patient, and that's it.